Hey everyone, welcome to the Hardware Meetup. It's so awesome to see everyone. Yeah, had so many registrations. There's like probably still registrations coming in, which is cool. And it means that everyone, is excited to come out and meet other people and see cool stuff. Has anyone, who hasn't been to a Hardware Meetup? That's awesome. That's awesome. And there were plenty of hands down. So yeah, and lots of familiar faces. So thanks for coming along. If you've never been to one of these before, what happens is we have usually like 3 speakers. They talk one after each other. There's like, goes for about half an hour. So we have some amazing companies here tonight. And I'm excited for everyone to learn about them. The first speaker we have is Joan from Freightfish.
Hello.
So Joan, what do you do?
Hey, so I'm Joan. I work as the lead control systems engineer at Freightfish. We're a startup based in Northland, and we're developing large-scale hydrofoiling ships.
Awesome. Do they look like this?
They look a little bit like that one. This was a prototype that we built last year. So this video was filmed in December last year. We've moved on from this design to now have a canard system. So that is a U-foil at the rear and a T-foil at the front. Despite how cool this looks, it was a little more stable to widen the wheelbase at the back.
Mm-hmm. Cool. So what do you do? Like, what does a normal day look like for you?
So for me, working in the controls team, we've got a couple of guys working there, and my day could look anything like a day could be working on the simulation. Over the past year, we've developed a hardware-in-the-loop simulator. So we have all the actuators that are running on the boat run on the desk. Then we have a 3D simulation running in a gaming engine that simulates the buoyancy models, the propulsion systems, the foil characteristics, and so that we can see how the boat is going to dynamically behave before we go out testing. So that could be a day. Another day could just be debugging a simple, stupid problem with a dud wire with salt getting way too far up it. Another day could be speccing a battery pack or developing a powertrain or validating a particular control strategy. It's just a massive variety of tasks. Just because it's a small team, it's pretty dynamic. Really, if you see a problem, you've got to dive in and fix it.
And how did Freightfish get started?
So Freightfish was started back in 2017 by our CEO and co-founder, Max Olsen. So he worked in a shoebox somewhere for a while, came up with the idea, got some cash together. And then last year we moved out to Wiri in Auckland, which is a pretty small little warehouse, pretty small little office, just 5 of us chipping away for the year. And we came up with the prototype in the video that you just saw. And later last year, we moved up to Northland just so that we could be a lot closer to the water. So it's pretty cool now, whereas in Wiri, our testing sessions would take an entire day. We'd have to drive all the way out to Mission Bay. We'd have to get the tide right. We'd, got to deal with Auckland traffic. And now it's just 2 minutes down to the boat ramp, and we can test any time of the day. And it's pretty idyllic, especially in summer.
Awesome. So you have, how many of these do you have?
So these are just prototypes. So this is our 1 to 10 scale prototype. We're just in the stages of finalizing our 1 to 5 scale prototype. So the next one is 1 ton, 6 meters, and we hope to have that flying early next year.
Cool. And my next question is, what is the point? Like, what are these for?
So the whole idea behind this is to create an environmentally friendly, fast, efficient way of transporting people and freight around the world. Effectively, we think that a lot of our waterways are somewhat underutilized in their capacity to move people. It's a lot more green than, say, for example, air freight to get goods across waterways. It's a fantastic way to move people. And yeah, I mean, the propulsion systems will be diesel electric, so it means that we can switch over from diesel when we're out of the harbors and back into electric when we're in the harbors. So it's great, just all around.
So why do you swap from diesel to electric?
So say, for example, there are some areas where there are noise restrictions around, or it's a lot easier to control. And then on some shorter routes, it's possible that you could even do it as a fully electric service.
Awesome. So what does the future look like in terms of like the immediate future and then the end goal or a bigger goal?
So for us at the moment, our focus is squarely set on getting this next prototype on the water and flying. Ultimately, this is our last prototype before we move to a full-scale vessel. So we'll be back on the hunt for money again, doing a capital raise in the first quarter next year. Pending that capital raise, we'll be building the first of our factories around the Marsden Bay area. So the whole idea is that we will be designing the boats, building the boats, and operating the service all under one umbrella, and doing it based in New Zealand. So the long-term vision is to have 400 staff working in One Tree Point to make this fleet. But yeah, in the next year, it'll be building that factory, which means that in early 2022, we can then be working on that first full-size craft, and then at the end of that year, we hope to have that on the water for prototype testing.
That's awesome. And do you need any help? Do you need anything?
Oh, we need so much help. Imminently, what we're looking for, we need power systems engineers to design the battery system and the drivetrain for the full-scale craft. Alongside that, hardware engineers to develop the flight control system, and not just in a prototype sense, but in a full production, mission critical, reliable sense. And then alongside that, software developers who have experience in developing mission critical visualization tools, both on the front end for the pilot, but also on the back end for all our telemetry systems. At the moment, a key part of our testing is getting all of our data real time back to quote unquote mission control. So while the boat is out on the water, everything is being transmitted over cellular, and in less than a second, we can see all that data visualized back home. And that will be a really key part to keep people safe on first voyages, and just understanding any problems that come up as they go. So it's as much of a marine problem as it is a full end-to-end data problem, really.
Awesome. Okay, I'm going to open up to questions.
At the moment, that's actually a question I can't answer. I'm on the controls system side, and so our power systems engineer is taking care of that. So sorry, I can't give you a number, so I won't make one up. Yeah, so at the moment, we're controlling the height based on a combination of sensors. We have sonar sensors, sensors on the strut to measure the height, and accelerometers, and then it's a fusion of all of those inputs to determine what that height is, so that we don't raise and lower the boat too radically. One of the key issues that we do have to address on the full-scale boats is underwater forward-facing sensing for, if there's a container floating just under the surface or anything that might be in our way. So that's a key challenge, because it's one thing to know that something is ahead of you, but it's quite another thing to actually then go and avoid it when you're traveling at 100k an hour with a lot of mass behind you, because it's very easy for the boat to fail if you turn it too sharply. So we will need to see a long way in advance in order to reliably avoid obstacles. So it's a pending issue for us.
So that's what kind of materials is it being built with?
So, so the prototype, all the struts and foils are all carbon fiber. We're just using wet laminated compression molding techniques for that. So we do that all in-house. We CNC the molds, and everything that you see has been made in our workshop. And then the aim is to do that on the big scale boat as well. Questions around whether the hull itself will be carbon, not 100% sure at the moment. It's right on the verge, but definitely the struts and foils will be carbon.
Oh yeah, how do you levitate the boat?
Yeah, sure. So the boat has underwater wings that make it fly. All of the wings have flaps on them that we actively control. So the boat in and of itself, it really can't be flown by just a person. It just wouldn't work. It's passively unstable, and so that means that the control surfaces need to be actuated many times a second in order to be able to keep the boat stably flying. And so if you want to fly higher, there's part of the strategy that will increase the lift up to a point where you reach that target height, and then the lift will back off again. So it's definitely underwater. Actuating things underwater is a challenge. I guess marine systems in general is a challenge, just in terms of sensors and knowing what's going on. Is something that we keep fighting with daily. But yeah, to answer your question, yeah, they're actively controlled foils.
Like, how many dolphins are we going to miss today or hit or?
No comment.
Yep.
Preferably sorry. Oh, sorry.
How far ahead would you like to be able to look?
Definitely above 250 meters, preferably around half a K.
What size payloads will they be intended to handle?
So the commercial boat is intended, say that the images up here are supposed to carry three 20-foot containers, so around 60 ton, which is comparable to the belly space of a 777.
What's the competitive landscape?
So the competitive landscape, there's a range of areas that we're looking at. Air freight is getting hit pretty hard because of COVID, and because freight is heavily subsidized by passenger flight, and because there's less passenger flight, the price of freight goes up. So there's a lot of short haul routes that we can look at as an alternative to air freight, even though we're slower than a plane. The fact that we can put the container straight on, hoon across and take the container straight off, as opposed to repackaging it into the belly space of a plane and vice versa at the other end, gives us a competitive advantage. There's also other areas such as ferries that we can look at. There's really, it'll be a market that we make. It's in that there's a lot of these spaces already filled, but this is hopefully something that can do it faster and more efficiently than those existing surfaces.
So are they meant to be fully autonomous?
So I guess the long-term view would be to have them fully autonomous, hopefully, but definitely in the short term, the marine sector doesn't even have a regulatory process for autonomous vehicles. It would be, I mean, let alone hydrofoiling autonomous vehicles. So the short-term aim is to have, I guess it's semi-autonomous in the sense that the flying aspect of it is autonomous, and it's like a drone in that you tell it to go left and right and up and down, but you're not really actively flying the boat. But it will be a very long-term step before we actually take the pilot out of the pilot seat.
The issue?
There are many safety issues. So that's and it depends what sector we'll be targeting. Like, say, if we're in freight, the regulations are very different to if we're carrying passengers, for example. So if we're doing freight, we could perhaps get away with having, say you always just have to think about how quickly can this boat decelerate and what impact will that have on the passengers on board. And it's a lot easier if you have fewer crew on board, and it may be as simple as having 5-point harnesses and full, just decking it out as if it was more like a race car. If it's for freight, if it's for passengers, balancing that against their customer experience that's going to be the tricky one. So yeah, it's going to be tricky, but at the same time, the nice thing about it is once you're flying, the experience for passengers is a lot nicer than being on these choppy seas. Like it's a pretty great thing, even if the prototype, to see when you're out there in the wind and the waves on the chase boat and you're getting hammered by the wind and the waves, and the boat is just gliding along. So as long as we build in those fail safes into the control strategy, it could be an extremely comfortable ride. Well, it depends on obviously a number of factors, but you can get around the 50% mark. But obviously you can keep going with those efficiencies and speeds in sea states that you could never think of doing that in a hull-borne mode. So it's a tricky question to numerically answer, but the gains are very real. Like when we're throttling on, we could be at 80% on takeoff, and then we throttle back to 30. We're accelerating, sort of thing. So it's pretty much.
How much does it cost?
How much does the boat cost? It depends what application it'll be for. So we're not planning on selling the boats as per se, because the services that we're hoping to run, we'll run with our team behind it as well. So the business will expand from being a engineering, purely engineering, to also being a logistical operation. And the reason for that is that because the tech is so new, it carries our brand and our name behind it. So it's hard to say what it will, or should I say, it's hard to share what it will actually cost, because that won't be a public figure. But it's affordable enough in a VC space.
Cool. What radar systems does it have on board?
So the prototype doesn't have a radar system on board, but the full-size vessel definitely will. That is something else that we're looking for, is someone who has had experience with off-the-shelf radar systems, vision systems, and above the water and below the water, so that we can, as per the earlier question, see things well in advance, both above and below. So if anyone fits that sort of bill, please come and talk to me afterwards. It's a role that we're looking to fill. So
can it go places a traditional vessel couldn't because of the foils?
Absolutely, yeah. It means that because these foils, so the front foil is able to fully retract upwards in front of the boat, and as can the rear. So, and then there's a secondary propulsion system that can make it taxi around harbours and those sorts of places. So that reduces the amount of water clearance that you need to 2 meters. So it means that you can go places that, say, conventional container ships can't. So yes, absolutely.
So that is, what do you build in-house? Because lots of development.
Yeah. Absolutely. So at the moment, anything that we can buy off the shelf, we buy off the shelf because of burn rate is limited, or the burn time is limited, should I say. But if we buy something off the shelf, we ensure that we characterize it so that we understand what that is contributing to the system. There are definitely parts that we can't buy off the shelf at the moment. Say, for example, we just couldn't find props that would work for at the RPMs that we were providing the propulsion that we needed. So we designed the props in-house, for example. We've done the struts and the foils in-house. On the electronic side, the actuators are off the shelf. It's tricky. One of the biggest challenges has been building a scale prototype for a big boat when the dynamic performance of those two things is so wildly different, and the power requirements are so wildly different, and then somehow taking learnings from that small prototype and being able to carry it through to the big boat. So say for the actuators, it was just not feasible weight-wise to have a full hydraulic system with an accumulator and all that jazz on the small boat. So we've gone for electrohydraulic systems on the scale prototype, and that means that we're sort of halfway there, but it's not the full step there. And then on the electronics hardware side, we'd get off-the-shelf microcontrollers, but we design all our own breakout flight boards, for example, and our communication protocols are custom and all that sort of jazz. So if I turn that off. Good. So yeah, it's a constant balance, and trying to see an item on that you finish for its total cumulative cost is the trickiest thing, to go, okay, well, I've made this myself, but it's actually cost me X number of hours versus I bought this off the shelf and the price is what I paid. I don't know if that answers your question, but yeah.
So that was around how do you kind of compete with other solutions?
Totally. No, and that's a fantastic question. I mean, the short answer is you'll never compete with conventional sea freight in terms of economies of scale. But then it's time versus cost. So we're not trying to compete with sea freight in the freight space. We're more trying to compete with high value items that need to get from A to B in a short space of time. And we think that we can compete with air freight on those grounds. Cool.
Awesome. Thank you so much for coming in and sharing. Will you be around for the rest of this?
Yeah, absolutely. So if any of this strikes a chord with anyone, I'll be around. Please come and talk to me. I'd love to hear your backgrounds, and and see, we're literally looking to grow the team with talented, passionate people, and it's super exciting to be here and just hear a couple more of your stories.
Awesome. Cool. Thank you. Hello, Anita.
Hi.
What do you do?
So I work for Dotterel. I create 3D printed solutions for our technologies that are looking to solve the noise problem of drones.
Awesome. So we showcased Dotterel, I think it was 2018. And I wanted to do a deeper dive into Dotterel, specifically around some of the 3D printing stuff they're doing, and just the general, recap, because I think it's really cool. And they've had continued success, and some really interesting stories are coming out of Dotterel now, which Anita's going to share more of. So, yeah. So who are you?
I'm Anita. Hi. So I grew up in a small town in the Bay of Plenty called Kawerau. I moved to Auckland about 10 years ago, and I've been with Dotterel for about 4.5 years now.
Awesome. Yeah. So how did you get started at Dotterel?
Wow. I met the founders at a previous startup that I worked for, and they were kind of testing the ideas out, and they were like, hey, we need someone to come help us design and 3D print stuff. Do you want to help? And I was like, yeah, sure.
And there's heaps of, how many Dotterel people here? One.
Hands up.
Wow. Awesome. Oh.
And their families. Yep.
And the family, yes, we've got family members here, which is awesome.
Yep.
Cool. So what I find really cool about Anita's story is she doesn't have any technical qualifications, but she's still working in a really amazing company. So yeah, I think people can do anything if they're really interested in it. Don't have to go back and study more stuff. You can just dive straight in. And I think in New Zealand, we uniquely, anyone can dive into these companies. So that's, what I love about your story. So let's go on to how Dotterel works. How does Dotterel create your products?
We have 2 research streams, and they're called passive and active. And so our passive technology are our acoustic safety shrouds, and our active technology is two-way communication payload for drones.
Right, okay, so there's 2 specific things
that help drive the project's forward.
Right, okay.
Yeah.
Cool. Let's see more of these.
Oh, sorry, I realized I was in charge of this. What is it? This? Oh, all right, so this is what I do. So for creating world firsts, such as our two-way communication payload, we need ways to test this stuff, to keep things safe and to mount them to our drones. And so that's what I do. I create these various contraptions that very soon get put out of date as we realize we need different electrical equipment, or we have new plugs or new mounting patterns, since things change between designs.
So what's the two-way communication? What does that mean?
Let's skip forward for that. So with the current generation of drones, they're deaf to the world around them. They're basically flying binoculars. And so with Dotterel, we looked at drones and what they are, what they can do, and we've gone with we want to develop technology that can help evolve the purpose of drones so that they can go from being flying binoculars to being two-way communication tools. So for search and rescue and fire, and actually help people.
Awesome.
So this is a representation of aerial audio. So we're able to speak to people through the drones. They'll be able to hear us and we can hear them in return.
Like you've all seen Minority Report.
And so I've got a video that shows aerial audio.
Cool.
Want to put it on?
What I was just trying to say might have been a call for help, it might have been critical instructions, it could have even been a threat. Up until now, there's been nowhere to tell because all UAVs are deaf to what is happening around them. At Dotterel, we've developed aerial audio, the world's first two-way audio communication payload that allows you to hear what is happening on the ground. Follow me. The aerial audio payload includes a first of its kind microphone array.
Real-time global processor with directional speaker linked to a remote ground station with a simple to use app interface.
This technology will open up new applications for UAVs, such as locating and communicating with survivors in search and rescue, allowing real-time interviews from UAVs and cinematography, and providing greater situational awareness for operational teams, keeping people safe. Dotterel's aerial audio adds the missing sense to UAVs, allowing you to hear what you could previously only see.
So you asked more about how we implement 3D printing. So this drone was one of our iterations of aerial audio, which was last year. And so all the parts in blue are printed on our Mark II, which is a continuous fiber 3D printer. So all these parts can have like aluminium type strength, which is really great. It's really strong. However, when we were at this point, COVID happened. And so we had to figure out a way to continue our workflow while we were at home. And so the announcements were happening and we're like, how do we keep making? And so the technical team basically all took a 3D printer home, we chucked them in our cars, we kept off, and we kept iterating, designing, refining while we were at home. And we kind of work out all the kinks, send either like the G code or we'll upload the file to a cloud-based slicer, and then the project leads can print them off and either put them on the drone or test them with the microphone. And then, so we came out of the first lockdown, and this is sort of what we had. We're like, great, this is really great progress. As you can see, lots of parts. Our desks often have various versions on them. And once we did this, we had some user feedback, and it was like, right, we've got to change this up again, and we need to put our audio processor unit on top of the drone instead of underslung because they needed the gimbal access. And so we were able to kind of, look at the design, look at, what we've done and how we can change that quickly and manufacture it in-house to get it working. And so now we have this. The payload is no longer underslung. It's now mounted on top of the drone. The mic housing is completely different. So now there's vibration dampening.
What's the payload?
So the payload is is aerial audio. So that's onboard processing for the MEMS microphone. So it comes on board and it can clean up the audio in real time, stream it to a ground station so you can hear what people are saying far away from you.
Mm-hmm.
Yeah.
Awesome. So yeah, what's been happening?
So I think it was about middle of the year we had some press come out that we were involved in the shooting of Mulan. And so this was one of our biggest projects to date with our passive technology. So that's the acoustic safety shrouds. And they house 30-inch rotors.
Cool.
And after that, we got some more traction with aerial audio. And so as of last week, we've been packaging up aerial audio into demonstration units. So last year, a couple of the team went over to LA, and so they demonstrated aerial audio to LA Fire. And so they were able to show that you can have someone stranded in a building, for instance, and you're able to fly up and have a conversation with them and figure out, what's going on and relay really useful information. And at the moment they kind of just have to throw a brick phone through the window. So this is a much more elegant solution to that.
So do they tie the phone to a brick?
I guess, or it's just a really heavy phone. More like a metaphor.
Awesome.
Yeah.
Cool. Yeah. So tell me more about the shrouds. That's obviously that's the other stream. So you've got drones that yell at people, and then drones that enable like they can be used in movies and things like that, where you have to be quiet or things.
Yeah. So with the nature of COVID, we've had to put that bit more on the back burner. But for the shrouds, that was another really useful. 3D printing was incredibly useful for that. It still is, where we're able to, print shrouds in-house and iterate a bunch, because they don't really need to, they need to work good enough for the time being. And so that's something that we've learned along the way, is identifying, one of the main problems you're trying to solve, and you move through them sort of one at a time, especially with 3D printing. So you can use your more low-cost materials that, they're not necessarily strong or resistant to much, but they're enough to test the idea, and then you can kind of go through the research and development process again and tweak it, and then you can figure out, okay, we've got this shape working, we've got this mounting system working. So now we can look at, how do we manufacture this for longevity?
Cool. What's next?
What's next? So, Dotterel, we're expanding. We're trying to get more people on board, all types of people, software, many different types of engineers. Basically, if you're interested in drones, making things quieter, and acoustics, come talk to me afterwards. There's our CEOs here, our founding team are here mostly, I think.
Like the whole family's here. So if you want to join us, Dotterel, you're totally covered.
Yeah. So yeah, come speak to me after. I'm happy to make introductions. And we're specifically really interested in looking at how our microphone payload can, not only go on drones, but it can go on just robots in general, because they are currently, the deaf as well. There's not much in the way of microphones being on robots, just because, they are quite heavy. And so we've got this, low weight and very smart technology that will work well for that.
Mm-hmm.
Yeah.
Awesome. Any questions? What's the weight of the drone?
I'm not sure. So for the drone that Aerial Audio is on is a Matrice 210. And we picked that specifically because that's sort of like an industry standard between like the various government and search and rescue agencies. And so with the payload, we can package it up, knowing that it'll work well on their unit, and then they can receive it and chuck it on and give it a go.
Cool. Yep.
No.
So that is, are you 3D printing more than just test components?
It's a mix. So the shrouds were a carbon fiber layer. We use 3D printing to mount the shrouds at one point. For aerial audio, a lot of the parts for that are 3D printed, whether it's kind of like your standard plastic FDM or SLS for the processor box.
Oh, have you built your own 3D printer?
No, don't really need to.
Are you planning to build your own 3D printer?
No. Yeah, so this is designed within the weight specs so that we don't negatively impact flight time too much. So they're still able to get decent time in the air. And with the shroud technology, that's kind of like a net neutral as well. No, so standard flight time for the Matrice, I think, is about 20 minutes.
Have you considered miniaturizing it like a fly?
So we're not in the business of making drones, just the payloads and stuff to be retrofitted onto them. And early days, aerial audio was rather big. It's very hard to make things off the bat small. And so over the years, it has gone from something which was probably about like this big to what can effectively fit in the box that's down here. So it's getting smaller, but it's not tiny.
Why was the drone used for Milan so big?
So that was a custom frame that was built, and that was built specifically to be able to carry their massive cinematography cameras, and so you need to have enough power to lift those. Yeah, it takes 2 people to carry that thing. So at the moment, we're just working on getting it on the Matrice, and then so are you talking kind of like counter-rotating drones? So the microphone works it's kind of got an active beam and a null beam, and so the null beam's cancelling out the rotors, and so of course when you add more noise you need to refine that as well. So in time, but for now just quadcopter.
Cool. At the back.
Yes.
So are they planning to use what they've developed for other industries, not just drones?
Yes, definitely.
So that's around, is the audio active, or does it need to be tweaked with each different vehicle?
It would need to be tweaked. So we're still working on that. So it gets depending on like how far away the microphone is. Minor tweaks.
Awesome. Maybe one more question. Yep.
So do you want to repeat that?
Couldn't they fly a drone, land it, and then communicate?
Yes, well, not always, no. For instance, let's say there's a suspicious boat or a vehicle. This is trying to replace people in the front line. So trying to make sure that your first responders, where there's like say fire or there's flooding or it's generally dangerous to send people. You probably don't want to just land the drone. That would also put it at risk of being probably just broken as well. Being able to record audio in the air also means that, like, let's say someone's lost, you're able to fly at altitude and kind of survey, and you can kind of detect where sound's coming from. You're able to get closer, and let's say they're stranded somewhere where it's very difficult to get to. That's where it really kind of excels.
Awesome. Cool. Thank you, Anita.
So there's another startup company called AKL, and they're working on faceware that actively filters pollution. No, I don't know a hell of a lot about them. I know them, and I know that they're looking for good people. They're looking for all sorts of engineers as well to come on board and help, build their product.
Yeah, have you seen like the clear mask with like the motors on the side of it?
And they glow and look
And it like covers.
awesome.
Yeah, so that company needs people. So if you're interested, this one. So if anyone is interested, chat with Anita. They are looking for people like desperately.
Yeah.
Yeah. And it's really cool, pretty cool technology, and kind of maybe relevant at the moment.
Yes, very.
Awesome. Cool, thank you.
Okay. Hi, my name's Matt. I'm an electrical engineer. Wouldn't it be great if we could just stop paying power bills? So that's my preface for my dream tech that I'd like to come true. I've called it nanogrids. I studied it in final year at uni. It's just an integration of solar panels, energy management, and batteries. Basically, in that year, I discovered that if you have a solar panel, you can get a return on investment. And if you have a solar panel and batteries, you don't really at the moment because batteries are too expensive. But if you add an energy management system, you can get a closer or shorter return on investment than you would if you just did either one of the other two options. And so the possibilities of this technology are really cool. It's a really simple idea. You link a bunch of houses up with this, and they all share power. If one goes out, then the others can support it, which means that if you have a natural disaster or some sort of issue or accident, you have basically an uninterruptible power supply.
Minute's gone. What do you need?
What do I need? I need people who can help me make this a reality. I don't know where to start, but I would like to know how. Thank you.
Awesome.
Hello everyone, my name is Malkiyat Singh. I'm a mechatronics engineer with training. I moved into project management. At the moment I run an immigration advice company, and I'm also growing organic vegetables. So for my organic vegetable farm, I'm looking at building some new cool projects. My mechatronics knowledge is a bit rusty. So I've studied lots of things. I worked as software engineer. But when I look at where the technology has moved in the last 15 years, it seems that, I am so far behind. So while I could attempt to solve every technical problem myself, so I'm reaching out for some of my projects where some of you young guys who are freshly actively involved in solving technical problems, as opposed to me being a project manager, motivating others to solve problems and removing hurdles. So currently I have two projects where I could use help. One project is a vegetable washing station, which will use some technology similar to nanobubbles, because I am harvesting rainwater. Water is a big shortage for lots of farmers who are growing organically, and getting a water bore is not really sustainable in my opinion. So that is a project which I would need help with. How do we make a sustainable model? And second project I'm working on is how do we generate biogas from farm animals? So making a systematic system of collection of cow dung, creating fermentation, generating biogas, and using it for electricity generation.
Wow.
So it's aspirational projects, but I'm trying to break it down into smaller chunks, and I'll be also willing to pay for somebody's time. So it would be not a project where you would just have to volunteer, but if somebody has any ideas, I'd like to chat.
Cool. Okay, so Rocos is a software company, and what do we do? So robotics engineers seem to be really good at some things. Making awesome hardware, robotics engineers great at that. Doing awesome computer vision stuff, machine learning, kinematics, really impressive mechanical designs. But there are some things that robotics engineers are really scared of. And connecting your robot to the internet is like the scariest thing for a robotics engineer. As soon as you connect onto the internet, all sorts of weird, horrible things happen, like security. So what does Ropos do? We basically provide a cloud platform for robotics. So we allow you to connect up your robot to our platform in a secure, reliable way. We provide tools for monitoring robotics. And we provide tools for allowing you to control your robots over the internet.
Something I didn't actually prepare you for, but what's your background?
So I am a robotics engineer, I guess. I come from a mechatronics background, not an internet stuff background. So I am kind of the example of a person who didn't want to do internety things.
And so when did you join the company?
So the journey, if we go back to maybe like 3 years ago, I was at a robotics company, and a couple of guys, Rocos founders, came and spoke to me, and they were talking about starting up a software company. They came from really strong cloud backgrounds, knew how to do big enterprise secure internet stuff. And so they came and said, we're thinking about starting a company. What would you like? So I basically gave them a huge list of things that I didn't want to have to do myself, like connect things to the internet and worry about security and worry about broadcast and worry about internet discovery and all of those things that from a mechatronics point of view really didn't seem easy. But they were like, oh yeah, we know how to do those things. So off they went, and like if we fast forward a few years, about a year later they came back and they made this product and it did all of these things that I wanted. And so about a year ago then I jumped over, and now I'm responsible for the mechatronics team there, which basically means connecting up other customers' robots to the platform and letting them have the same kind of benefits. So what has happened in that time? We've started a bunch of kind of partnerships from Microsoft, iFlyTech, big Chinese robotics company, and then if we come all the way forward to recently, the one that people are interested in tonight, Boston Dynamics. So creating partnerships with a bunch of robotics companies. And what does that mean in terms of Boston Dynamics? So Boston Dynamics make a robot called Spot, pictured here. Spot is a quadruped robot. It has a 90-minute runtime, can carry a 14 kilo-ish payload, and can move at about 1.6 meters a second. It walks on legs, which makes the locomotion really flexible. Also kind of cool. Can do things that a wheeled robot, tracked robot can't do, like go upstairs. And so these Spot robots seem really awesome, and companies buy them. And you get your Spot robot, and what can it do? You can drive it around with a remote control, and you can give it a kind of a automated mission called Auto Walk, where you drive it along and then it will replay that exact same kind of thing that it was just doing. So you're a company, you bought your robot, you've driven it around, you're like, man, this is awesome. What do you do with it now? Because you've basically got this huge remote control toy.
Try and kick it over like they all do in the videos?
Yeah, pretty much. And you spend like the first day doing that and like trying to take it downstairs and trying to
ride it,
crash it into things, and yeah, exactly. But then your boss is like, okay, we need to make it do something useful to justify this investment now. And you find some problems. For an actual enterprise robotics application, you don't just need something you can remote control around. You need something that you can buy hundreds of and connect them all up to your management system, your enterprise software suite.
You mean like robot soldiers?
Yeah.
Okay, yeah.
Pretty much. And you want to be able to connect them all, see how they're all doing. So if one of them has a problem, you know that that's the one you need to go and do something about. You want to be able to collect diagnostic data, understand what it means for your whole fleet, and you want to be able to automate them in a way that's not just someone drives it around and it replays that exact same mission over and over again. So our Boston Dynamics Spot by itself doesn't do these things, but that's where the Rocos platform comes in. So we're basically providing extra capabilities on top of what a robot natively does that makes it useful for a business connecting over the internet to control lots of these things.
Awesome.
What else you got?
Future plans.
So, as you can see from the slide a few back, we're slowly kind of making partnerships with more and more robotics companies, and as part of that, adding in progressively more kind of features, basically to do what I just described. We want to be able to gather all this telemetry data and produce really sophisticated kind of dashboards where you can see exactly what your one robot's doing, but also see exactly what your fleet of 100 robots is doing, and maybe it's not just a fleet of 100 spots, but maybe you've got 100 spots and 100 drones and 100 submarines and 100 other robots as well. So bringing those all in together and being able to automate them in a way that's easy for people to do. The people who are going to be using robots, if you're a successful company scaling out, are not going to be robotics engineers. The people who are going to be using your robots are going to be regular people of some variety. And so being able to produce a solution for automating robots is something we work on, basically producing what you could call like a kind of a visual programming environment that works on robots, or a way of kind of programifying the concept of like mission planning for robotics.
So what did you do to get your hands on one of those Boston Dynamics robots? Did you like give away your firstborn or some kind of blood sacrifice or something?
So the spot we've got here today is on lease to us from Boston Dynamics, and as part of our kind of partnership program with them, I guess we get preferential terms.
Right.
So they see in us something that adds onto their product. So we're helping them sell their product into potential enterprise end users who need to use something. You need your spot to be something more than just a toy.
Yeah.
So hopefully we are helping them drive mass adoption of their product, which has been good for us.
Cool. Should we move to help?
Yeah. How can you work with us? There are basically two ways you can help us out. One is that we want to work with companies making stuff in New Zealand and overseas. So if you are making robots, and the definition of robots is quite wide, we've got things connected up at the moment ranging from like mobile robots, submarines, autonomous trucks.
Wasn't this Freightfish?
Freightfish is definitely something it's speaking to. We've got engineers on stuff from Dotterel as well, so it's all a small community, as it turns out, in the robotics industry in New Zealand. We want more people out there who are looking to connect up their technology online to talk to us and see what our platform can potentially do for them. And at the same time, we are also hiring. So we are hiring mechatronics engineers for my team. We basically are writing software, mostly in Golang, but we're really looking for engineers who have huge domain knowledge in things that our customers are going to be interested in. We're working with companies who are world leading in things like SLAM, kinematics, and machine learning, and so we want our engineers to have that same level of understanding of those technologies. Platform, we're looking for back-end and front-end developers for the platform team. We are making stuff in Angular. We have microservices in Node.js and Go. All of our stuff is built on Kubernetes. So people who have skills in those areas, also very interested to hear from you. We're even looking for a bunch of other roles: QA, design, product management, sort of service delivery stuff as well. So, please feel free to take a look at the careers page on our website, and if you think you could help us out, then put in your application. So, next slide, maybe. Oh, yes. Okay, demo. So, the thing you've all come along to see, Flynn, mechatronics engineer / dog trainer, is somewhere at the back, hopefully. We have with us our Boston Dynamics Spot robot, which Flynn is now going to bring out, and which hopefully we'll be able to see what it looks like on our platform at the same time. So whilst Flynn's deriving it, with the remote control, you can see up on the screen here what it looks like to control Spot from our platform at the moment. You can see over here we're zoomed out miles, but here's Spot, a little 3D model of Spot. And as it walks, you can see that the little model Spot on the screen actually matches Spot as it walks along. You can see we've got live video coming through from the camera on top of Spot. So what's happening when Spot walks around at the moment is that our software running on a computer on Spot's back is going from that computer over Wi-Fi to Flynn's phone, from Flynn's phone all the way to our servers in the United States, all the way back from our servers in the United States to here, and ending up on Flynn's laptop and then on the screen that you can see. So the Spot has got a bunch of sensors around the periphery. You've got 2 on the front, 2 on the sides, 1 on the back. They're Intel RealSense type stereo camera pairs, which it uses to perform collision avoidance. So it won't walk into things as much as it can. You can walk into it if it's standing still. It won't try and get out of your way. And those cameras are useful for navigation, but not necessarily for providing good sensor outputs for whatever your application might be. So you can see on top of Spot, we've got a whole bunch of additional payload. In this case, we've got a 360-degree camera and a pair of stereo cameras that we're using for R&D. So by itself, Spot doesn't necessarily do very much. You typically want to bolt on extra things to add those extra kind of capabilities to get it to do stuff.
Questions? Yep.
Did you name it Harry McCleary?
That question was, is it named Harry McCleary?
Yes, although you keep that on the quiet because Boston Dynamics don't like you giving the robots names. They don't want you to anthropomorphize them. But as it turned out that by the time we'd got it out of the box and read through the instructions and discovered that piece of information, it had already been named Harry McCleary. So that probably tells you something about, I guess, people's relationship with robots. Spot can look very lifelike, especially when it's peering around rather than just standing still. Flynn, can you? Oh, yeah, there we go. So when it's like this, it's really quite hard for people to treat it as though it doesn't have some kind of lifelikeness to it. But it's kind of contrary to what you want to use these robots for. You really want to be sending these kinds of robots into situations where you don't want to be using people. So you don't want people having to attach to them if you're then going to send it into a burning building. In its base form, it has no hearing capability, but the payload that is mounted on the top of it here, which comes from Boston Dynamics, does have a microphone of some variety. Though I couldn't be more specific as to what.
The question was, have you controlled multiple robots with the system before?
Yeah, so I guess our platform is designed as a framework for managing whole fleets. So you want to be able to control different robots at the same time. If we look up at this screen here, you can see up in this corner we've got just the one robot loaded in at the moment, but on that particular page you could have multiple robots loaded in and click to select between them to allow driving one round with the controller, then switching to another one. If you've got autonomous missions, then you might want to have each of those robots doing autonomous behavior simultaneously.
So is it intended for robot arms and things like that, as well as walking robots?
So we're working with at least one robot manufacturer who makes a stationary ARM product, but on the whole, we're more focused on mobile robotics. So we're not really trying to compete in the factory automation space, which is already quite well served.
So what if the system got hacked?
So I mean, the potential for system, for connecting a robot online and having it be hacked is, the thing that really worries robotics engineers, and is the reason why robotics engineers like the idea of farming that part out to a company who has the expertise to make sure things like that don't happen. So, like I say, our founders and our platform team come from really strong cloud backgrounds, and so there's a huge amount of work that goes into the architecture and design of our system to make sure that security is really paramount. For instance, the agent, the piece of software that my team's responsible for and what actually gets installed onto the robot to connect up to our platform, is designed so that it only ever dials out. You don't have to open up any inward ports on your robot to use our system, which provides like an extra layer of security. And that's just one, I guess, out of your kind of standard risk Swiss cheese model to making sure that overall you're protected.
So can the US government tracking migrants across the border who decides to unleash a payload, can they cancel that?
So the other side of that question is that is the customers often ask is around data privacy, and basically we as a company don't have any access to or ownership over our customers' data. So if you're the robotics company and you're our customer, we don't actually have the ability to even see what you're using our platform for in terms of the data that's flowing through. So I think that is a really important characteristic for companies who are developing things like machine learning or AI models, where they want to make sure that they're the ones in control of their data. So in that situation, we would probably be essentially blind to that kind of thing, because data just comes through our system without us being able to see what it is. I think at that stage, our commercial team will be looking at the terms of service, but we certainly have a range of customers who we're working with, from private companies through to government agencies. And so I think our focus is on making like a really secure platform that means that you can design the rest of your system without having to worry about the fact that you're going over the internet. And the overall nature of the system you're creating is then left up to you, the roboticist.
So that's like, how long does it take between telling the robot to do something to when the robot does it?
Yeah. Control latency is a really interesting question, and it came up lots in my last job. At the moment, when Flynn's driving around, we're going via our servers in the US. Your control latency is about 200 milliseconds, which is very close to the round-trip ping time. On the other hand, the video that you're seeing is coming directly from that camera to Flynn's laptop via a peer-to-peer connection, and typical latency on that over a LAN like this, you might be getting like 3 milliseconds latency on the wire, or 3 milliseconds plus whatever your Wi-Fi latency is. So we are working on technologies both designed for topologies where you're going via a server, and topologies where you're operating on a local network. So the agent that we install onto the robot basically requires a piece of general purpose compute, so a Linux computer, a Windows computer, if such a thing existed as people installing Windows onto their robots. In the case of Spot, by itself, there's no piece of general purpose compute in the current model of Spot that we can install onto. So that's why on this one we've got an NVIDIA Jetson TX2 computer mounted on the back, which is running our agent. So generally the things you need is some piece of Linux or otherwise compute that our software can run on, and a connection to the internet somehow.
Use Wi-Fi?
Yeah, so we don't stipulate how you connect so long as you can provide a routable IP connection.
So Emirate's wondering how she could directly benefit from the Boston Dynamics robot.
So a really common industrial application that our either partners or users are talking to us about at the moment is using Spot for industrial inspection. So say you have some kind of manufacturing plant or a power station or something where there's a whole lot of equipment that you want to inspect as part of some maintenance program, but it's inconvenient or dangerous to send people in to be doing it. Then robots like Spot are really attractive because say the case of like a high voltage switch yard, you might be able to send a robot like Spot into it without switching everything off. So that's both potentially making cost savings in terms of time and consistency of the data you collect, and also keeping your employees out of harm's way. Yeah, absolutely. So the automation framework that we're building is designed so that it'll be possible to easily kind of plug together things like machine learning models and real-time decision making, so that you can automate Spot or another robot to go into an environment, move around, collect data, make decisions based on that data, and then send you back maybe only the most important information that it collects.
So that's what sort of R&D are you doing with the additional cameras?
One of the interesting characteristics of the Spot robot in particular is the way its navigation system works, and how you can provide commands to it. And so what we are doing at the moment when we're driving it around is that we have one stereo camera on top, the Stereolab Z2, which is being used to perform real-time SLAM for pose estimation. And then we're doing a bunch of transforms to convert between the pose that camera is seeing and the pose of the robot itself, and issuing commands to the robot in different frames of reference. We can support ROS, and I would say that the majority of users of our platform at the moment have ROS-based robots, but the Spot is not ROS-based by itself. And so we have in our agent, we have a plugin module that supports ROS, and we also have a separate plugin module that supports Spot. We, at the moment, actually have ROS installed onto that computer, again, for one of the kind of SLAM and video R&D tasks we're doing, but it's not actually related to what we've been doing with Spot today in terms of driving it around.
So this is what goals and milestones do you have for your company over the next 10 to 15 years?
So I think that we're really convinced that what we're at today is kind of the dawn of the golden age of robotics, that the kind of confluence of technologies to enable large-scale deployments of robots into industry is just starting to come together. And so we think that in the next 10, 15 years, industrial robotics is going to go from something you see in factories with stationary robotics to the ubiquitous use of mobile robotics. And what we'd like is to see that when industries look to how they can use mobile robotics, they're going to realize that having a framework for managing their fleets and automating their operations is going to be a real necessity. And we'd like that the Rocos platform is the platform of choice. Yeah, definitely. So one of the key design considerations in this automation system we're building is being able to give you control over where the automation processes that you might construct or set up are going to run. So you might want some processes to run natively on board the robot because you need them to run in an offline environment. or you might be able to offload some of that into the cloud, say, because you think that your system is going to have good connectivity. Yeah, so the question is, given the ping times to servers in the US, for instance, what is the plan for offline processing in that regard? So yeah, interesting question, and an interesting way of addressing that, say, is Rocos has recently won the Spark 5G challenge, and so as a result of that, part of the R&D we're doing in the next few years is going to be looking at the use of 5G technologies for robotics. And one of the cool things that 5G does is allow the potential for edge compute in 5G cellular towers, so that might allow the possibility of running some processes off-board the robot, but really close to the edge.
Cool. That is it.